With the outline, here's what you can expect in this lesson. So, in this lesson, we will be defining modern day science. Like, science is a well-known term, but, you know, where does the term originate from? What is the translated meaning? Define modern day science in terms of the scientific method and how the scientific method came about as the result of a 16th century scientific revolution. So, we have been ever since the scientific revolution in the 16th century, human civilization, quality of life, technological innovation, the population has been growing exponentially each generation. And with that, more and more people are becoming educated in these scientific disciplines. So there are well over several hundred branches of science. And we'll look at some of those, actually. We'll look at the most important ones. But what they all have in common is that they follow the scientific method. Outline the four main branches of modern science and highlight the most important sub-branches. So when you think of science, you might think of mathematics, you might think of physics, you might think of chemistry, you might think of biology, geography. Okay. Chronicle the history and evolution of the scientific enterprise from prehistory through the classical era, which is ancient Greece, up until the age of enlightenment. So again, if you've been following previous lessons, this should be familiar ground for you, familiar territory, familiar knowledge, because we've already talked about it. I'll try to introduce it as best as I can for you. Profile the early Greek philosophers, Socrates, Plato, and Aristotle. So they're not necessarily scientists, but without them, you know, some of the later scientists, you know, they took influence from these three. So Copernicus, the later important scientists, as far as scientific revolution goes, is Copernicus, Galileo, Francis Bacon, Descartes, or René Descartes, and Isaac Newton. So hopefully some of these names are more familiar to you, like Isaac Newton. Let me see here. Okay. So, yeah. These words, I imagine, are probably unfamiliar to you now. And I'm going to define them for you now. And then when we come across them later on in the lesson, you'll see why they matter, okay? So the first word is artifact. Artifact. And an artifact is an item, a historical item. So when we talk about something found maybe at an archaeological site is where you know, archaeologists, scientists who are digging up remains of human dwellings, settlements, cities, and so on. They can kind of piece together and get a picture, a general idea of you know, what kind of a people they were. So when we look at like how advanced technologically people were, based on their you know, based on the artifacts that we find in archaeological sites, you know, we can kind of speculate, form theories or hypotheses about what kind of a people they were. right? Like our understanding of history, like we have recorded history, that which has been written down, and then we have prehistory, that which, no written records remain if ever they were created. So we have to come up with a picture, and we have to imagine basically what life was like before recorded history, and we try to do that through examining artifacts. We could also talk about artifacts like forensic scientists who are trying to solve a crime or an accident, a disaster, or something like that. They will also collect artifacts to try to put together a theory of what took place, basically. If you imagine like a plane crash, car crash, or something like that, evidence, artifacts, police and forensic scientists will try to gather the evidence. We call that an artifact of evidence. So a piece of evidence, physical evidence. Astronomy is a branch of science that has to do with studying the stars, studying the night sky, studying the heavens, and particularly looking at the motion of the stars and the motion of the planets. An atom. So what is an atom? Think of it as the smallest unit of matter, right? If we were to look very closely through a microscope, you would see that matter, physical matter, is kind of energy. The smallest unit of matter are atoms. And then the study of chemistry looks at these elements, these atomic elements, and how they can combine to make molecules, which can be useful for different kinds of materials. A conclusion. So again, the scientific method, science, is all about solving the mysteries of the living world, of the living natural world and the universe. And there's no way for us to get a complete picture of what came before and what may come after and what exists beyond what we can see. So the scientific method, uses inductive thinking, where we gather evidence as much as we can. We try to test a hypothesis. We ask a question. We come up with a possible theory, one that we can make a prediction about. If the theory is true, then this thing will happen. And if depending on the results of the experiment, the hypothesis gave a reliable prediction or it didn't, that's the conclusion, basically, whether the hypothesis is correct or not. This is an interesting word here, cosmology. So, in the study of philosophy and religion, we've looked at religions and we've looked at philosophies. Cosmology is just a word to describe our belief system about the universe. So there's basically two kinds of cosmologies: the geocentric and heliocentric model, one where the Earth sits at the center of the universe and all things move around it, and the heliocentric, where the Earth is part of a solar system that orbits around the sun, and the sun is part of a galaxy that the sun is a star that is part of a galaxy that is part of the galaxy is very big, and there are many galaxies, an infinite number of galaxies. So the difference between cosmology is, one is that we are at the center of everything, and the other is that we are a tiny, tiny, tiny part of something very, very vast, and that influences how we live our lives. And scientists are always testing, testing these two theories. The best theory that we have for the time being is the Big Bang theory, that hundreds of millions of years ago there was a kind of an explosion, and hundreds of millions of years later, here we are now, and as time goes on, the universe expands. So, we don't know that for sure. That's kind of a scientific theory, but it's the best one we have. So that's our cosmology, basically. That's our understanding of the universe. A discipline. So I talked about the scientific branches, the 4 branches, sub-branches, scientific branches. Another word for that is discipline. So you can't be an expert in all areas of science. You can't really be an expert in chemistry and physics and astronomy and mathematics and biology. There's just too much information. It takes too long to know, to know everything there is to know in each one of these disciplines. So, students need to choose a branch, specialize in it. That's a discipline, scientific discipline. Dogma. So we'll be looking at the history and evolution of modern day science, how we came to, how science came to be so important and popular in our modern world. Prior to, when we had the Industrial Revolution, the technological innovation that came about as the result of the Industrial Revolution, the Scientific Revolution, the assumptions about sort of the cosmology of the universe that we lived in didn't stand up to the scientific method. So dogma is a word to describe a statement that, it's a belief, basically. A religious belief is the best way to put what dogma means. Dogma means a religious belief or an ideological belief that says that the universe and the world and people are a certain way, but it's not based on scientific evidence or the scientific method. It's really just an opinion. Empiricism. So we'll get to the definition of empiricism a little bit later, but empiricism is, again, very, very important when discussing the scientific method, where we observe, basically. So I guess if you went back several hundred years before the scientific revolution, people had their religious texts and their religious beliefs and the sort of the beliefs and dogmas that were passed down from one generation to another, like, history, where we came from and how societies evolved. We look to history, the history books, and religious texts are a source of historical record. But we don't actually see with our own eyes what took place. So empiricism says that, in order to really have an accurate picture of what history was like, we need to find some kind of physical evidence that can confirm or can validate the kind of events. And if we can't, then it's not worth really forming any kind of opinion or hypothesis about, basically. So there are certain things that we can't understand scientifically. There's certain things about the universe that we live in that we can't quite grasp at it. And so there are certain areas, let's say, certain ideas that scientists just won't entertain because it can't be observed, or it can't be experimented properly. So empiricism is that we really if we want to follow the scientific method, we need to we need to formulate an experiment that can gather evidence that we can observe. That's empiricism now. And there's a definition later that will explain it a little bit better. Ethics, again, we're really looking at philosophy for most of this lesson, and ethics is well, there's morals, and there's like the teachings that are passed on down the generations as to what is right and wrong. Some people would say that this is culturally bound, in that certain societies, certain cultures value a certain type of behavior, I guess. Ethics should be like what any individual who can think rationally, any individual who attains a degree of education should be able to rationally think for themselves what is correct behavior, I think. Again, like the function of education is to instill ethics into people so that they grow up to be responsible citizens, responsible adults that can sort of maintain the peace and harmony of a society so that the society can continue. So it will look at, where that idea came about. Evidence, we talked about artifacts, we talked about empiricism. Evidence is a kind of a data or information or artifact, a thing that validates, supports a hypothesis. A hypothesis is a sort of a possible belief that something may be true. Evidence is something that supports that. Evolution, the idea that societies develop and improve, and living organisms also adapt to the environment. Experiment, it's a kind of a formal activity. Scientists conduct experiments. Controlled experiments, where they can take measurements, do observation, and test whether or not the hypothesis can make a prediction. Hypothesis. So the hypothesis is a belief of what may be true. A theory. To investigate. So there's research and analyze and experiment. You can kind of see these terms below. To investigate is to do a thorough, rigorous study where we leave no rock unturned. An investigation is one that is very thorough and systematic in its attempt to understand an event or a phenomenon, phenomenon, something that happened, basically. Logic. Okay. Logic is, in a system has many parts that work together, and within a system there are sort of rules or laws that govern how the parts should interact with each other. So logic, think for example cause and effect, how Isaac Newton, who discovered the laws of gravity and motion, noticed that an apple fell from a tree, right? So the effect was the apple falling from the tree, and Newton had to come up with a hypothesis as to what was the cause, what pulled the apple down. So we're not able to kind of see with our eyes or understand how gravity works. All we can do is hypothesize how it works. We can set up experiments and make hypotheses that can make predictions, and this is what Newton was able to do. Newton understood that there was some logic behind why things were pulled to the earth, basically. He understood that there was some relationship between where we are on the surface of this planet, and when we look up to the sky and we see all of these stars and planets moving around each other, and the moon and the sun and so on. He understood that there was some kind of logic, mathematical logic behind that. Observation, again, to just observe, to watch, to look, to try to understand, to document a phenomenon. So, this is kind of this is a very abstract topic here. We're talking about the ways in which we think about, the natural world that we live in. And science is a product of philosophy, and philosophy that had sort of developed and evolved for centuries, many, many centuries. For many, many centuries before we had technology and instruments that could perform measurements, computers that could do calculations, all we had was, our minds. And so a phenomenon is a word that they use to describe anything that they're observing, right? A weather phenomenon. A philosopher is somebody who studies reality, studies truth, studies thinks about how we perceive the world, and tries to formulate in words, communicate to another person, so that we can come to a shared sort of mutual understanding of, what it is like to perceive and what it is like to think and so on. Like, philosophy is a very, we'll get to some of the main philosophers later on in this lesson. Physics is the study of motion, movement, gravity. It's kind of like an applied mathematics, using mathematics to make predictions about objects in the world that we live in. So there are some constants like gravity, for one, that we need to measure so that we can then apply mathematical formulas to be able to make predictions. That's kind of what physics is about. And then there's astrophysics, looking at the universe. A prediction. I've been talking about predictions for a little while. A prediction is to be able to accurately guess or accurately speculate that something will happen in the future. Skepticism is sort of a philosophical standpoint that one should not accept the truth or validity of anything that one is told unless one can, through research, analysis, experimentation, observation, arrive at the same conclusions for themselves. Empiricism, skepticism. To speculate, again, is to guess or make a prediction with less certainty. To look at anything that is possible, past or future. Supernatural. So again, like going back to religious dogma, a lot of phenomenon were just explained as supernatural events. The gods would control weather events or would interfere in human affairs, so on. So that's a supernatural, that's what the supernatural means. And a system. Okay. And then below that, a system basically is sort of a complex, something that is complex with many, many parts, but belonging to a whole. That's the best definitions I can give for these kinds of words. And below that, we can see that we have the scientific method. So what is the scientific method? Let's look at that a little closer. Here we go. Okay, so the way that a scientist sets about proving an idea is to state the problem, to propose a problem, then to try to research, find out about the topic, come up with a hypothesis or a possible explanation, predict the outcome of the problem, then do an experiment or do multiple experiments to sort of test whether or not the hypothesis makes an accurate prediction, analysis, and conclusion. Compare the hypothesis to the experiment's conclusion. Okay, so let's move along now. What is science? Yeah, the word science comes from the Latin scientia, which simply means knowledge. There we go. So when we think about science, we think about we have inherited through many hundreds of years the work of great scientists who have dedicated their lives to understanding the world that we live in, the natural world, the universe. And so because it has been tested through the scientific method, there's no need to really question or be skeptical about these types of claims, because the scientific method is a reliable one where anybody can test the hypothesis that these scientists proposed. So it's factual information that can be verified by anybody for themselves. So that's why science is knowledge, and that's why we rely on it now in the modern world so much. Modern science is a systematic enterprise, a formal activity done by a group of people. So, a scientist needs to sort of graduate through an academy before one is qualified to, contribute to the growing body of scientific knowledge. Modern science didn't come about until the 19th century. So prior to that, philosophy or natural philosophy was the precursor to science, and it was a mental discipline rather than a technologically driven one. What's going on here? So the scientific method is a way of gathering empirical evidence, a way of gathering observable evidence, a way of gathering information, facts, data, artifacts, evidence, observable, testable results, conducting experiments and recording and measuring those results, to form explanations or hypotheses that can make predictions in order to validate or invalidate a theory, in order to prove or disprove, a theory, an idea, a belief, about the natural world and the living universe. The goal of the scientific enterprise is to make what is unknown or supernatural known and rational and understandable. Now, how did science come about? Well, individuals have been observing and speculating about unknown forces in the natural world for millennia, for thousands of years. Furthermore, as societies have evolved to become larger and more complex, the need for technological innovation has helped us to overcome problems that threaten our safety, make our work easier, and our quality of life more enjoyable. And here we can just sort of see an early depiction. I'm not sure when this was made, but this is when I'm talking about cosmology, this is a kind of artistic rendition of what the cosmology was. So you can see symbols or metaphors of animals, depicted in this, moving around this celestial wheel, I guess. So when people looked at the sky, like when we look at the sky, we think we think of stars and planets and satellites and galaxies and all of these, distant galactic bodies that are millions and millions of light years away from us, and we're just a tiny little piece of that. But going back as many as 500 or 600 years, people firmly believed that our planet was the center of a created system, right? And when they looked to the sky, they would see sort of supernatural entities, these deities or these celestial beings, and so they gave those things names and personalities. So this is mythology here. There's all kinds of, I guess, psychological meaning embedded in this type of a picture here. So this is the supernatural dogmatic explanation of the universe that we live in, or artistic representation. So, what we couldn't explain, we would just try to imagine. And living together, needing to do work, I guess, gave us the motivation to innovate technology. So we have these tools used for building or tool making, construction, medicine, and of course weaponry. So it was like architecture and building and medicine and sort of defense that, and farming, agriculture. All of these activities prompted us to technologically innovate, which is a kind of a form of science, but it wasn't a formal, systematic mental discipline or academic discipline by any means. It was just people trying to come up with ways of getting work done, basically. Human civilizations didn't arrive at a system of writing until hundreds of years after their evolution. For example, in China, Egypt, and Mesopotamia, and other places. Evidence of their scientific understandings are found in their artifacts. For example, tools for farming, building, making clothing, travel, keeping time with a calendar, medicine, and weaponry. So these early artifacts that we find in archaeological sites are what inform us of what kind of a civilization this was and how scientifically advanced they were. And this is a picture of an abacus, one of those counting devices. Trying to move on to the next slide here. Here we go. Now, so this is the classical, this is a map of the Mediterranean and the classical world. You have the Mediterranean Sea in the middle, Europe above, Africa below. There's Egypt, the purple one. And across from Egypt, the yellow one is Greece. So these two are important. Okay, this is ancient Greece, Athens. And, this is what the early Greek writing looked like, the early Greek alphabet. And it was the Greeks that really gave us some of the fundamental mathematical principles. They did they did some amazing. They were able to arrive at some amazing scientific understandings long ago, and for a long time, this sort of scientific reasoning was lost to civilization for hundreds of years, right? It was only rediscovered around the era of the Enlightenment, which was, I think, the 14th, 15th century. Anyway, so because of things like plague and war and totalitarianism, I guess. Societies were unable to really safely engage in scientific inquiry for fear of suppression and censorship. So anyway, the Greeks were a very open and democratic type of a society, and they really believed in openly discussing ideas and testing assumptions and so on. And they were brilliant mathematicians. So here we see some of the Greek philosophers. And I'm trying to move on to the next slide here. Having a slow internet tonight. There we go. Okay. So, classical era science. Modern science as we know it today didn't come about until the 19th century, when technological innovation allowed for more precise experimentation and measurement, leading to a variety of specialized scientific disciplines or branches to emerge. So we'll see after the 19th century and the scientific revolution, different scientific disciplines suddenly came into being, and scientists, these scholars, I suppose, would then dedicate their lives to specializing within a narrow scientific discipline. Prior to that, you had just natural philosophy, which looked at many different things. The ancient Greeks dedicated their time to pondering the nature of their world, communicating and debating their ideas with each other. The great thinkers became masters of philosophical academies, or schools, where students would become scholars of the ideas discussed or debated, putting these ideas and discussions into books to preserve knowledge through generations. So through dialogue and discourse among each other, debate, through that interactive activity of communicating with each other, they were able to share ideas, and it was in those conversations that some really great ideas were proposed, and then the students would basically just write down everything that the masters were saying. These masters were sort of old, wise thinkers. They had been well trained by masters who came before them, and they had spent their life teaching as well as debating other masters. So anything that they said was really quite profound. And it was through their conversations, because they didn't dedicate their time to writing. That's kind of what their students were there for. They would just communicate their ideas, and people would question them, and people would argue with them, and all of these conversations were written down and then studied later. So we're just waiting for the next slide here. Here are some of those early Greek scientists, those early Greek masters. Leucippus, yeah. So we have the idea of the atom now. Like, the atom is fundamental to our cosmology, that matter is made up of tens of millions of individual atoms. Well, it was an ancient Greek pre-Socratic philosopher that originally proposed that, just from observing with his own eyes. Basically, he was the first to develop a theory of atomism, the idea that everything is composed entirely of various imperishable, indivisible elements called atoms. And a lot of scientific terminology, a lot of scientific names come from Latin, which are adaptations of Greek. So Archimedes was a mathematician who developed a theory of numbers. Euclid developed a system of geometry. Pythagoras was another mathematician who devised practical mathematical equations used in modern day physics and geometry. Ptolemy was an astronomer who studied the stars. Hippocrates was the grandfather of medical science. So we have mathematics and like geometry, number theory, physics, chemistry, and medicine here. These individual thinkers basically just, their ideas, the scientific discipline is in some ways named after them. Okay, so we're talking about the pre-Socratic era. Now we're going to talk about Socrates and Plato and Aristotle. So what happened was there were these in Greece. You had these three cities: Athens, Sparta, Troy, this Macedonian region. Greek philosophers and historians were keen on educating their citizens as a means of self-preservation. So there's a book called The Odyssey and the Iliad, written by the historian Homer, who talked about the great war between Sparta and Troy. The great tribes such as Sparta and Troy had destroyed themselves as the result of corruption and war. So this was a catastrophic war that took place, and the Athenians sort of looked on, and they wanted to sort of ensure that this kind of catastrophic war could never happen again. So this is why philosophy was so important. Philosophy, ethics, politics was so important to them, because they believed that sort of an uneducated, irrational society would allow dictators to come in and make terrible decisions, such as lead the country into war. Socrates and the Athenians believed in individual morality as the path to a long-enduring civilization. So Socrates was a very controversial, outspoken critic of the ruling powers, and it's because he wanted to sort of educate students to think for themselves, and that he wanted basically to encourage individuals to become leaders of their own lives and leaders of their own communities. Socrates was a teacher. In his day, the sons of wealthy Greeks would go to academies to learn from teachers the ways of living that were considered to be good. Socrates was unique to other teachers because of his use of the Socratic method. So this is another reason why Socrates is a really, really interesting historical figure, in that he didn't tell people what to think. He used the Socratic method. He encouraged students to think for themselves by only answering their questions with deeper questions. In doing this, his students would be guided to an eventual conclusion that couldn't be challenged by counter-argument. So if you read any works of Plato, it's basically just a dialogue that takes place over hundreds and hundreds of pages between Socrates and his students and his debating opponents, those that would disagree with him. And he would just keep arguing and arguing and arguing, but he would do it through basically like reflecting their arguments back to them and asking why. He would continue to ask questions that would get people to look at the deeper causes or the deeper reasons why they held these beliefs and ideas. This is the Socratic method. And the Socratic method taught by Socrates and written about by Plato influences formal scientific discipline today. Okay, now we're going to look at Plato and Aristotle. So, Plato was a student of Socrates. Socrates never committed his ideas to writing. Socrates was put to death for challenging the religious order of the day. So, although Greek Athenian society was a very open-minded and almost a scientific type of a society, certain religious beliefs, certain religious dogmas couldn't be questioned, and so he went too far in upsetting sort of the in upsetting the ruling powers by speaking heretically about their religious belief system. and this cost him his life. Plato was very angered by this, and therefore dedicated his life to writing dozens and dozens of books about Socrates and his philosophical ideas. So we have Plato and we have Socrates, and obviously Plato added a lot of his own ideas into, like he would add a lot of his own ideas into his books. But Socrates is the main character in all of his books, who was a real character, like a real person. So Plato is a bit of a biographer, but also like a philosopher. He may have imagined some of these conversations to prove his own theories. Aristotle was an ancient Greek philosopher, teacher, and the grandfather of natural science. So without Plato, there wouldn't be Aristotle. Without Socrates, there wouldn't be Plato. And without the great war of Athens and Troy, there probably wouldn't be a Socrates. Aristotle was a student of Plato who went on to start his own school called the Lyceum. And with the help of his students, Aristotle is said to have authored as many as 170 books. Only 47 exist today. Alexander the Great, king of Macedonia, who went on to conquer most of the Mediterranean and Persian countries, was his most famous student. And these are books by Aristotle. Aristotle's ideas on physics and metaphysics informed philosophers and religious scholars for centuries. Modern scientists like Isaac Newton, who redefined our understanding of the universe, would have had to study the works of Aristotle in order to challenge the old ideas. The influence of Aristotle on Western philosophical scientific thinking cannot be underestimated. So we have modern science today, but modern science is the answer to kind of what Aristotle had tried to propose. Much of it is still useful today. That which was lacking, we have come up with new ideas, basically. But these are ideas that were sort of given to us by Aristotle. Aristotle was a great. He asked many really great questions. He was he had a very curious mind, inquisitive mind. And he was very scientific in his investigations. Like, he was very thorough in his investigations into the natural world. So we have zoology and botany, two scientific disciplines. Aristotle's most unique accomplishment was his classification of as many as 500 animals and plants. So he would look at the different, features of animals and say, this belongs to this kind of a species, that belongs to that kind of a species. Charles Darwin, the later evolutionary biologist, would propose his theories many centuries later. Aristotle's observations into the natural world would result in his great theory, telos, that everything had its cause and consequence, and that everything was the result and cause of everything else in a greater whole. Aristotle believed in a living universe that was well ordered. Aristotle is perhaps better known in the modern day for his contributions to the social sciences, primarily politics and ethics. So there are 4 branches of science. One of them is the social sciences, like history, politics, ethics, sociology, economics, philosophy, psychology, if I didn't mention that, the arts. So those are the social sciences. It was Aristotle's firm belief that through the interdisciplinary study into mathematics, nature, as well as history and the arts, one was able to attain a noble character and therefore have a good life. So Aristotle was a scientist interested in the natural world, but he was very much a moral, ethical teacher as well. And very much interested in the systems of governance and the development of character, how to lead a good life, to be part of a good sort of society. Aristotle had an advanced conception of economics and politics. He compared many different political belief systems with the interest at arriving at one that ensured individuals had the freedom and security so that philosophical and scientific projects could be successfully carried out. And after Athens fell, science was put on hold for a very long time.
Aristotle was born around 384 BC in the ancient Greek kingdom of Macedonia, where his father was the royal doctor. He grew up to be arguably the most influential philosopher ever, with modest nicknames like the Master and simply the Philosopher. His first big job was tutoring Alexander the Great, who soon after went out and conquered the known world. Aristotle then headed off to Athens, worked with Plato for a bit, then branched out on his own. He founded a little school called the Lyceum. French secondary schools, the lycées, are named in honor of this venture. He liked to walk about while teaching and discussing ideas. His followers were nicknamed Peripatetics, the Wanderers. His many books are actually lecture notes. Aristotle was fascinated by how many things actually work. How does a chick grow in an egg? How do squid reproduce? Why does a plant grow well in one place and hardly at all in another? And, most importantly, what makes a human life and a whole society go well? For Aristotle, philosophy was about practical wisdom. Here are 4 big philosophical questions he answered. 1. What makes people happy? In the Nicomachean Ethics, the book got its name because it was edited by his son Nicomachus, Aristotle set himself the task of identifying the factors that lead people to have a good life, or not. He suggested that good and successful people all possess distinct virtues, and proposed that we should get better at identifying what these are, so that we can nurture them in ourselves and honor them in others. Aristotle zeroed in on 11 virtues: courage, temperance, liberality, magnificence, magnanimity, pride, patience, truthfulness, wittiness, friendliness, modesty. Aristotle also observed that every virtue seems to be bang in the middle of 2 vices. It occupies what he termed the golden mean between 2 extremes of character. For example, in Book 4 of his Ethics, under the charming title of Conversational Virtues, Wit, Buffoonery, and Boorishness, Aristotle looks at ways people are better or worse at conversation. Knowing how to have a good conversation is one of the key ingredients of the good life, Aristotle recognized. Some people go wrong because they lack a subtle sense of humor. That's the bore, someone useless for any kind of social intercourse because he contributes nothing and takes offense at everything. But others carry humor to excess. The buffoon cannot resist a joke, sparing neither himself nor anybody else, provided that he can raise a laugh, and saying things that a man of taste would never dream of saying. So, the virtuous person is in the golden mean in this area, witty but tactful. A particularly fascinating moment is when Aristotle draws up a table of too little, too much, and just right around the whole host of virtues. We can't change our behavior in any of these areas just at the drop of a hat, but change is possible, eventually. Moral goodness, says Aristotle, is the result of habit. It takes time, practice, encouragement. So Aristotle thinks people who lack virtue should be understood as unfortunate rather than wicked. What they need isn't scolding or being thrown into prison, but better teachers and more guidance. 2. What's art for? The blockbuster art at the time was tragedy. Athenians watched gory plays at community festivals in huge open-air theatres. Aeschylus, Euripides, and Sophocles were household names. Aristotle wrote a how-to-write great plays manual, the Poetics. It's packed with great tips. For example, make sure to use peripeteia, a change in fortune, when for the hero things go from great to awful. In Titanic, Leonardo DiCaprio gets Kate Winslet, great, then they hit the iceberg, awful. And anagnoresis, a moment of dramatic revelation when suddenly the hero works out their life is a catastrophe. But what is tragedy actually for? What's the point of a whole community coming together to watch horrible things happening to lead characters, like Oedipus in the play by Sophocles, who by accident kills his father, gets married to his mother, finds out he's done these things, and gouges out his own eyes in remorse and despair? Aristotle's answer is catharsis, which is Greek for catharsis. Catharsis is a kind of cleaning. You get rid of bad stuff. In this case, cleaning up our emotions, specifically our confusions around the feelings of fear and pity. We've got natural problems here. We're hard-hearted. We don't give pity where it's deserved. And we're prone to either exaggerated fears or not getting frightened enough. Tragedy reminds us that terrible things can befall decent people, including ourselves. A small flaw can lead to a whole life unraveling. So we should have more compassion, pity, for those whose actions go disastrously wrong. We need to be collectively retaught these crucial truths on a regular basis. The task of art, as Aristotle saw it, is to make profound truths about life stick in our minds. 3. What are friends for? In books 8 and 9 of the Nicomachean Ethics, Aristotle identifies 3 different kinds of friendship. There's friendship that comes about when each person is seeking fun. Their chief interest is in their own pleasure and the opportunity of the moment, which the other person provides. Then there are friendships that are really strategic acquaintances. They take pleasure in each other's company only insofar as they have hopes of advantage of it. Then there's the true friend, not someone who's just like you, but someone who isn't you, but about whom you care as much as you care about yourself. The sorrows of a true friend are your sorrows, their joys are yours. It makes you more vulnerable, should anything befall this person, but it's hugely strengthening too. You're relieved from the too small orbit of your own thoughts and worries. You expand into the life of another. Together you become larger, cleverer, more resilient, more fair-minded. You share virtues and cancel out each other's defects. Friendship teaches us what we ought to be. It's quite literally the best part of life. 4. How can ideas cut through in a busy world? Like a lot of people, Aristotle was struck by the fact that the best argument doesn't always win the debate or the battle. He wanted to know why this happens and what we can do about it. He had lots of opportunity for observations. In Athens, lots of decisions were made in public meetings, often in the agora, the town square. Orators would vie with one another to sway popular opinion. Aristotle plotted the ways audiences and individuals are influenced by many factors that don't strictly engage with logic or the facts of the case. It's maddening, and many serious people, especially Plato, can't stand it. They avoid the marketplace and populist debate. Aristotle was more ambitious. He invented the art of what we still today call rhetoric, the art of getting people to agree with you. He wanted thoughtful, serious, and well-intentioned people to learn how to be persuasive, to reach those who don't agree already. He makes some timeless points. You have to recognize, acknowledge, and soothe people's fears. You have to see the emotional side of the issue. Is someone's pride on the line? Are they feeling embarrassed? And edge around it accordingly. You have to make it funny because attention spans are short, and you might have to use illustrations and examples to make your point come alive. We're keen students of Aristotle. Today, philosophy doesn't sound like the most practical activity. Maybe that's because we've not paid enough attention recently to Aristotle.
Now we're moving on. Like, there was a period of history where Athens and Rome fell to into war and chaos in the medieval era that followed, and scientific investigation really wasn't possible for a variety of reasons. Now we're moving on to the 16th century. This is Copernicus, an astronomer and mathematician who challenged the geocentric model of the universe that planets and stars, or celestial bodies, moved about the Earth at the center. Up until Copernicus, the primary body of knowledge, the primary text, was the works of Ptolemy, Greek astronomer. So the ruling political institution of that era, the Catholic Church, tried to suppress scientists like Copernicus because it threatened their system of cosmology and therefore the faith of the church's followers. So there were certain things that people could observe about the stars that the church couldn't explain. And more people like Copernicus were conducting experiments. His observations and calculations into the orbiting paths of the planets couldn't be reconciled by the church, by the church's explanations. And so began the scientific revolution. So people really did look to the church as divinely endowed, divinely appointed, let's say, as having the final say on what kind of a universe we live in, that it's all perfectly explained by the church. When Copernicus was Copernicus was the tipping point for people to kind of look beyond the church to find answers that religion couldn't. So religion had a very important role to play in terms of like restoring peace and stability in a world that was in a continent, Europe, that was in the grips of war and just terrible behavior. So religion did play a very important role in civilizing, pacifying society, but then when it came to explaining the natural world, couldn't do that. So scientific revolution. We had individuals like Galileo, who built one of the earliest telescopes. He used the telescope, so he basically built off of the ideas of Copernicus. He used the telescope to monitor the orbiting planets and their moves and their moons. This is Francis Bacon, a 16th century philosopher important during the scientific revolution. His ideas included skepticism, questioning, rigorously testing popularly held beliefs. Empiricism, using experimentation and observation to arrive at conclusions. So during the scientific revolution, during this 16th, 17th century, more and more people were deciding to become like full-time scientists. This came with costs. This came with like going against the powerful religious institutions, and all of the risks associated with that, in terms of risks to one's livelihood. And then of course there was like, it was a brand new kind of career. So Francis Bacon would write sort of manuals or essays, talking about here's the best way to organize your scientific research, or organize your research. Inductive reasoning. So through gathering evidence, through observation and testing, evidence can be interpreted to agree or disagree with the scientific hypothesis. Again, like you had all of these different scholars trying to work together, collaborate together to build scientific knowledge, and then they would have these disagreements, and they needed to come up with a uniform system that everybody could agree on in terms of whether or not an experiment was properly conducted, or whether or not a hypothesis is like empirically testable or not. So that was the idea of Francis Bacon. René Descartes was another great philosopher, a bit of a metaphysicist and mathematician. Anyway, so Descartes furthered Bacon's ideas. He also was a mathematician, and his ideas would be taken up by Isaac Newton. And here's Isaac Newton. Enlightenment era mathematician and physicist who wrote the great book Philosophia Naturalis Principia Mathematica. Natural philosophy, principles of mathematics is the translation there. Newton is considered to be the last of the natural philosophers. So we've been talking about, from Leucippus and Hippocrates and Archimedes and Pythagoras, Euclid, Socrates, Plato, Aristotle, and then these scientific revolution thinkers, Copernicus, Bacon, Descartes, and so on. These are just the natural philosophers. Newton was the last of them. And then after Newton, we have modern science. Anyway, so what he was able to do in his lifetime, classical mechanics is a branch of physics. Then you have like quantum mechanics and astromechanics, I think, astrophysics, laws of motion, universal gravitation. So looking at larger bodies, just looking at like what happens here on the surface of the planet, looking at larger bodies, laws of planetary motion, and optics, how light works. I might as well show this since we're going into overtime.
A logical date for the start of the Age of Reason is 1642, the year of the birth of Sir Isaac Newton, the single most important figure of this new historical era, and the same year that the great Renaissance scientist Galileo died. However, some historians prefer to say that the Age of Reason actually began in the year 1686, the year that Isaac Newton published what many consider to be the greatest scientific book ever written, the Philosophiae Naturalis Principia Mathematica, the mathematical principles of natural philosophy, a book that was to radically change both scientific thought and method for centuries to come. In order to get a feeling for this era, let us discover what was happening in England during Newton's childhood. Isaac Newton was born in this house near the English village of Grantham in the year 1642. At the time of Newton's birth, 35 years had gone by since the founding of the colony of Virginia, and 22 years had passed since the Pilgrims landed at Plymouth Rock. The year of Newton's birth was the year that the English Civil War began, that saw the Parliament locked in a deadly battle with the Crown, and that turned into an economic class struggle led by wealthy merchants and Puritans against the monarchy. By the time Isaac Newton reached the age of 7, the English Civil War had ended with the execution of King Charles I. And for most of Newton's youth, England was ruled by a Puritan named Oliver Cromwell, who governed under the title of Lord Protector. The monarchy was finally restored in the year 1660, just 1 year before Isaac Newton entered Trinity College, here at the University of Cambridge. Immediately after finishing his university studies, Newton decided to return to his rural home to escape from a re-emergence of the Black Plague that was starting to spread outward from London to other English towns. By the year 1665, this most dreaded of diseases had taken tens of thousands of lives in England alone. But in spite of this fact, Isaac Newton experienced a burst of scientific insight never matched before or since in human history. During a brief 18-month period, he worked out the basics of a new branch of mathematics called calculus. He made the crucial discovery that all the colors of the rainbow are invisibly present in ordinary white light, and wrote out the mathematical explanations for this effect. He was able to understand and mathematically formulate the principles of gravity while watching an apple fall from a tree here in his garden. And at the same time, he described the physical laws that govern the motion of objects, calculated the masses of the sun and planets, and predicted the paths of comets. And all of these discoveries were also written down in precise mathematical language. But perhaps Newton's greatest achievement was the approach he developed for solving problems that we now call the scientific method. Before Newton's time, science consisted largely of a mixture of observation combined with religious mysticism. And this approach rarely yielded predictable results. In fact, the lack of a consistent logical method to science accounts for its slow rate of progress up to this time. However, in contrast to the old ways, Newton's scientific method was based on 3 essential points: observation, generalization, and experimentation. By using this method, the facts were allowed to speak for themselves in a pure, simple, and above all, rational way. And so it was that Isaac Newton completed a scientific revolution begun in the late Renaissance by Nicholas Copernicus, and as a result gave birth to a new era that we now call the Age of Reason.
Great. So, if you've ever been curious about Isaac Newton, it's interesting to know that a lot of his great scientific discoveries were made while living under quarantine. And hopefully we'll have more to say on Newton in later lessons as well, because we will be looking at the later scientists, the modern era scientists. So we're talking about scientists. There's not a whole lot to talk about up until the 16th, 17th century. Trying to move on to the next slide here. And then we had sort of the scientific explosion. So the 19th, 20th century, we have hundreds of scientists known for their contributions in each individual scientific discipline. This is biology and Charles Darwin, physics again with Einstein, psychology with Sigmund Freud, and computer science, and this is Alan Turing. Okay, so we're going to sum it up, or we're going to sort of conclude here. And as promised at the beginning, I wanted to tell you what the scientific branches are. I think this will be useful for those of you that are students and are taking science and are deciding which field to specialize in. Maybe you want to be an engineer or something like that. So I'm going to give you some terms. The scientific method is a way of investigating the natural world or universe phenomena. Okay, so just whatever can be observed, whatever can be investigated, and gaining knowledge or correcting and integrating previous knowledge. So through observation, experimentation, we can either learn something new, or we can kind of correct a mistake of the past, or we can integrate, we can bring two ideas together, synthesize them. I think Einstein was one of those people who synthesized and corrected the ideas of Newton with other scientific discoveries that were being made in his day as it related to electromagnetism. It is based on observable, empirical, measurable evidence and subject to laws of reasoning, both deductive and inductive. Inductive thinking, inductive reasoning is interpreting, looking at evidence and coming up with, using our minds to interpret conclusions. That's the power of the human mind, basically. Human mind cannot be replaced by a computer. Empirical research and experimentation. Gaining knowledge through direct observation and experience is what empirical research is. Experimentation, this is the process of conducting a scientific experiment. Ask a question, make observations, form a hypothesis, which is a explanation, a proposed, not yet tested explanation about the question and or phenomenon. Okay, form predictions that test the hypothesis, test the prediction or the hypothesis through controlled experiments. So I will get to a part 2 that looks at modern science, and we will come back to this.